Hello everybody. In this video, we'll learn how to compute probabilities for the normal distribution using Excel. So we'll go over a few examples. So the first one is where we have X is a normal distribution with mean 54 and standard deviation of 8. So I've written this down as 8 squared here, and 8 squared gives us the variance. So the mean is 54 and standard deviation is 8. Now we're interested in finding the probability of X being lesser than 30. Now, just a quick note here, normal distribution is a continuous probability distribution. So whether X is equal less than 30 or, X being less than 30 is actually probability of X being lesser than or equal to 30, and so on. So lesser than and lesser than or equal to, greater than and greater than or equal to, they're all equivalent because we're dealing with continuous probability distributions. So what's the probability that X is lesser than 30? Well, the first thing you want to note is the mean, which is 54, and standard deviation, and we want P of X less than 30. And the Excel function for this is norm.dist. Okay, so we want to say, the first argument here is you want to find the probability of X being less than 30, so you put 30 here. And the next argument is the mean. The next one is the standard deviation. And then you say yes, true to cumulative, because you want to find the probability of X lesser than or equal to some number, which is the traditional form for a cumulative distribution function. So you say yes and enter, and that's the answer. Okay. Probability of X being less than 30 is this. I'll encourage you to check these answers with the applet that we tried in class to make sure that you're getting the right answer. So use the applet as a guide and reference, because it'll help you easily visualize the different values and areas and probabilities. And you can always cross-check if your answers from Excel are right by checking in with the applet as well. Now let's look at the second one. What's the probability of X being greater than 56? We have the same mu and sigma here, it's 54 and 8. And we want to find the probability of X being greater than 56. And I'm going to, it's very easy to compute cumulative probabilities in Excel. So following what we did in the binomial and Poisson distribution videos, I'm going to express this as 1 minus probability of X being lesser than or equal to 56. I'm going to express this in terms of its complement. And when we do that, it makes it easier to find the values in Excel. So 1 minus P of X being lesser than or equal to 56 is 1 minus norm.dist 56. The mean is 54. Standard deviation is 8. And I'll say true. And there we go. That's the probability of X being greater than 56. As always, you can check with the applet to see if your answers are matching up. The next one is a little bit different. We want to find the 80th percentile. So for instance, if I want to compute 80th percentile is the value where is the value in the distribution such that 80% of the value is below 80% of the distribution falls below this particular value. That's the definition of a percentile. So if we want to translate this into a mathematical statement, I want to find the number k such that the probability of X being lesser than or equal to k is 0.8. That is, the probability that you find a value, there's a probability, there's an 80% chance that 80% of the distribution lies below this particular number. And 80%, when you translate that sort of a frequency into a probability notation, we can write down percentiles in this way. So we want to find k such that the probability of the distribution falling below this number is 0.8 or 80%. Now, so we want to use the inverse of the particular function that we've been doing so far. So given the probability, we want to find the number. Earlier, we were given numbers and asked to find probabilities. Now we have to do the reverse. So the function for that is called norm.inv, norm inverse of the normal distribution. And this has 3 parameters. The first value, not parameters, 3 arguments. The first argument is called probability. And the probability is actually the probability of the distribution up to that point. Or so in this particular case, when you're looking at the percentile, this probability value here will be 0.8, which means that 80% of the distribution falls below this particular point. 80% of the distribution is to the left of this point. So that's the meaning of the first argument. The second argument is the mean of the distribution, and then we have the standard deviation of the distribution. And when I compute the answer is 60. So when you have a normal distribution with mean 54 and standard deviation 8, at the point 60.73, when you compute the probability of x being lesser than or equal to this point 60.73, the probability of that expression will be equal to 0.8. So that is when you p of x being lesser than or equal to 60.732 is actually equal to 0.8. Okay, so we arrived at the 60.732 once we knew what once we knew the probability that it was the value was at the 80th percentile. Let's try one more. We want to find the 60th percentile. Probability of x being lesser than or equal to some number k is now 0.6, meaning 60% of the data values are below this number k. So we're going to use the norm.in again. 60th percentile means the probability of values below this number is 0.6. The mean is 54, standard deviation is 8, and the answer is 56. So this essentially tells you that the probability of x being lesser than or equal to this 56.02 was 0.6. And that's how you compute percentile values in Excel. And you can always check the answers with the applet here as well. Let's do one more. Now we have another normal distribution with mean 6 and standard deviation 2. And we want to find this probability of x lying between 3 and 9. So we can rewrite this as probability of x being lesser than 9 minus the probability of x being lesser than 3. I encourage you to check the classroom lectures to see how you can visualize this. And this is fairly straightforward. And I mean, less than and less than equal to are all equivalent. So this could be the same thing as this. And now I know how to just use the norm distribution to compute the answers. Norm dist 9, 6, and 2 true minus norm.dist number 3, 6, 2 true, and the answer is 0.8664. Again, check with the applet if your answers are correct. The third one, I'm going to leave this as an example for you.